welcome. This section will cover 3.2. We're going to look at points or slope-intercept form and how to graph equations. And so at first we discuss whether or not a certain point is a solution to an equation. And the way we go about doing this is simply let's substitute. Let's substitute x and y in for our equation, and let's see if we come up with a true sentence. So remember, in our ordered pairs, the first coordinate is x, the second coordinate is y. So we're just going to substitute these values. So -4 equals 3 times 0, take away 4. Anything times 0 is 0, so -4, does that equal -4? Yes, it does. Because this is a true sentence or a true equation, then yes, it is a solution. Let's look at a second one. I gave you one example of each. Remember, our first is x, second is y. So 2 times -1 minus that negative right there is that negative right there. Y is a +3 equals 4. -2 subtract 3 is -5. -5 is not equal to 4. This is a not true statement that it's equal. So is it a solution? No, it is not. So how do we find solutions? How do we graph a line? This is an example of a linear equation. So we know that when we come over here, it's going to make some type of line on our graph. It could be going this way. It could be going the other way. We will see when we get to those table of values. So give me just a second here to get rid of my line. There we go. There we go. Okay. So you get to pick the values that go in for x. We're going to choose x to be anything we want it to be. We're going to plug it into our equation, and then we're going to figure out what that corresponding y value would be. I like to have a couple negatives. I like to have 0. I like to have a few positive. You wouldn't want to pick something like x equals 100 because that would be really annoying to graph. And so we're going to choose, I like to choose -2, -1, 0, 1, and 2. And we're going to plug in those x's. So 3 times -2, subtract 1 more. 3 times -2 is -6. Take away 1 more gives us -7. 3 times -1, subtract 1 more. 3 times -1 is -3. Subtract 1 more is -4. 3 times 0, subtract 1. Anything times 0 is 0. Take away 1 more. It's -1. Let's get into our positives. 3 times 1 is 3. Take away 1 is 2. And when we plug x equals 2, and 3 times 2 is 6, subtract 1 is 5. So now we have a really nice list, and maybe 5 points is a little bit overkill, but it's definitely going to give us a nicer reference by which to graph. So now these are the coordinates. So I'm going to go left 2, down 7, and I'm going to plot these points. Left 3, down 4. I'm not going to go left or right any for 0. I'm just going to go down 1, right there on the y-axis. Right 1 up 2, right 2 up 5. And if you graph this correctly, it should all line up. Sometimes we have to make some homemade graphs when we're sketching out things, and it doesn't always line up pretty, which is why I wanted to do this on the computer screen, because then I can have that nice coordinate grid. Make sure that we add these little arrows to the top and bottom, because that indicates that we understand that that line is infinite. It goes forever. All right, what happens, I want to do one more of these, and this is a really tedious way by which to graph. So I'm going to jump the gun here just a little, and after this example, I'm going to show you the shortcut, which technically does not come up until later in our chapter, but I just don't see any reason not to do it. So we're going to go y equals 1/2 x plus 2. All right. So if I apply the same rules for this graph, so you can see my ability to write freehand a straight line right there. That didn't go well. All right, I still need to make my table. If I choose the same values I did last time, if I pick -2, -1, 0, 1, and 2, if I plug a 1 in right there, I'm going to end up with a fraction. And now I'm going to have to graph a fraction, which is kind of a hassle, and there's an easier way to do it. So this is going to come up later in our course. There will be times where you want to think through what would make sense to choose as values. Well, if I picked only even x values, I wouldn't really have the same issue. So I'm going to pick -4, -2, 0, 2, and 4. And that way, when I substitute, the fraction will go away. It'll cancel itself out. Let's look. 1/2 times -4 plus 2. Half of -4 is -2. Plus 2 is 0. Half of -2 is -1 plus 2 is 1. If I plug in 0, half of 0 is 0 plus 2 is 2. If I plug in, let me erase just real quick here so I have a little bit more space to work. If I plug in 2 for x, half of 2 is 1, plus 2 more is 3, and half of 4 is 2, plus 2 more is 4. And now when I go to graph, I don't have any fractions. -4, 0, left 4, up and down nothing. -2, 1, 0, 2, 1, 3, and no, sorry, not 1, 3, 2, 3, 2, 3, and 4, 4. There we go. All right. Take a straight edge or something like that and try to get all of those at once. Sometimes I have to adjust a little bit like that. That's a pretty good estimation. And then we want to make sure we have these arrows at the end. All right, how do we shortcut this? Well, we look at something called the slope-intercept form of the line. It is y, I typed it here, I'm writing it bigger, y equals mx plus b. This guy right here tells us what the slope is. And we have a lesson upcoming about slope, so you might want to pause right here, go learn a little bit about slope, and then come back, because you kind of got to take the whole chapter as one. But it is and many of you might remember lessons on slope, but this is a much easier way to graph. So this is the slope, and this is what we call the y-intercept. So our first example, and this is where it hits the y-axis. Where on the y-axis will my graph hit? And I think you'll get the hang of it once I do a few examples. So here, 1/2, the number in front of the x is always the slope. So my slope is 1/2, and my y-intercept is 5. So all I'm being asked to do in this first example is, can you pick out the pieces? What do? if it's not in this y equals mx plus b form? Well, we're going to solve it for y. So the first thing I'm going to do, this is why we did that lesson back in chapter 2 with the formulas. So if I have 2x plus 3y, I need to get this 2x to the other side. So I'm going to subtract it over here. Bring that 3y straight down. And this is that example I mentioned in chapter 2, where since we want it to be mx plus b, I want to write the x term before I write the constant. So negative 2x minus 18. We are one step away from having it in the proper form. So we have y equals negative 2/3 x minus 6. You can pause the video and try C. Oh, sorry, didn't even identify the slope and the y-intercept here. The 2/3, the slope is the negative 2/3, and the y-intercept is negative 6. If you'd like to pause and try C, be my guest. We're going to jump this 3x to the other side. Bring that negative 4y straight down. Minus 4y equals negative 3x plus 8. Divide by negative 4. Divide by negative 4. Divide by negative 4, and we get y equals, we have two negatives, negative 3 over negative 4, so that's going to give us a positive 3/4 x. Positive 8 divided by negative 4 is a negative 2. When I highlight this, this is my slope, and this is my y-intercept. All right, I'm in my classroom here this morning, and I haven't moved around enough, so all my lights just went out. So I'm pausing. You don't know I'm pausing. I am sitting at my desk at Peoria High School, and I have motion sensors for lights, and since I haven't moved in 10 minutes, I was just sitting in the dark there for a moment. All right. So how are we going to use this to graph? If you are brand new to graphing and you don't have a memory of doing this in the past, pause right here, go learn a little bit about slope, and then come back and if it might be helpful, okay? So this is our slope here, this 2, and our y-intercept is 3. So you can write that down if you'd like. Our slope, the m, is 2, and we are going to want to write this as a fraction. All slopes are going to want to be written as a fraction, and our y-intercept is 3. All right, here are the steps. Graph the y-intercept first. And then we're going to count out the slope. And I'll explain this, review this again if you've already seen the slope video. So count out the rise over run for the slope. And then we're going to connect the dots. So very first thing I do is go to this point right here. It's going to hit on our y-axis. Where is on the y-axis, where does it equal positive 3? Up 1, up 2, up 3. There's our y-intercept. From this point, don't start at 0, 0. From this point, count out our slope. We always go up or down first, and then we go either to the right or to the left, depending on whether or not we're going in a positive direction or in a negative direction. So because this is positive 2 over positive 1, what is think to yourself, what is positive? Up or down? Hopefully you said up is a positive direction. So we go from this dot, not 0, 0. From this dot, we go up 2. And then the bottom number of the fraction is a positive 1. Where are numbers going in the positive direction? To the right or to the left? And again, hopefully you said to the right. And so from this dot, we would go up 2, right 1. Done. Up 2, right 1. Done. You can continue to do that. You really only need 2 points. I just want to show you that the pattern continues. Think about how up 2, right 1 would look exactly the same as down 2, left 1. Notice how this is going to line up here on these dots. Down 2, left 1, because 2 negatives is the same as a positive. Down 2, left 1. Throughout the line, the pattern continues. So there's the line right there, and we're going to draw these arrows here at the end. So that's how we graph. Let's do another one. That's the end of this page. All right, so I have a whole bunch of examples here. Here's another one that doesn't look like a fraction, but it will be if we just put a 1 underneath. So at any point, pause, try things on your own. We're going to go to this back number first. This is going to be our y-intercept. So we're going to go up 1, put a dot. And then my slope is -2, so I think that would be a down direction, over a +1, so that would be going to the right. So down to right 1, you can do it a couple times if you'd like. Down to right 1, down to right 1. Notice that that would be the same thing as going up to left 1. Up 2, left 1, up 2, they all line up. Take a straight edge and draw your line. I need to straighten mine out just a little bit. There we go. Make arrows at the end, especially if, kind of side comment here, not this line, but let's just pretend over here where we don't have anything. If you draw a line and you just have these 2 dots and you just do something like this, you're not really showing me that you understand that the line goes through all these dots. You don't need to be extreme about it. You don't need to do something like this, but you do need to show that you understand that it is an infinite situation. Okay, we'll just, oops. Let's see if I can delete that quickly. Fair enough. All right, moving on. This one is not in that y equals mx plus b form. So this is why this is what I wanted to practice earlier in this lesson. Let's solve it for y. In order to figure out what the y-intercept and the slope are, we need to put it in this form, that y equals mx plus b. So we're going to solve it for y, which means we're going to jump that 4x to the other side. 2y equals, write the 4x piece first, minus 4x plus 12, divide by 2, divide by 2, divide by 2. So y equals a -4 over a +2 is a -2x plus 6. Total coincidence. I just picked numbers at random to type. So this is just coincidental that this is the same slope as before. All right, think through what we're going to do. We're going to go up 6 first. 1, 2, 3, 4, 5, 6. Put our dot. My slope is down 2, right 1, down 2, right 1, down 2, right 1. And draw our line. I did that one a little quicker, figuring you're probably catching on to the pattern. All right, now there's all sorts of weird exceptions. So like this one looks really strange. Y equals X. I don't see a y-intercept, and I really don't see a slope. If there's not a number in front of that x, remember there's always a 1. So the slope is going to be 1 over 1. Or up 1, right 1. Because it's a positive 1 over a positive 1. So we're going to go up 1, right 1. There's no y-intercept showing. So if there's nothing there, think what number represents nothing? 0. So we're going to start at 0, put our dot, and we're just going to go up 1, right 1, up 1, right 1, up 1, right 1. Or we could go down and to the left. 2 negatives make a positive. And draw our line. You can pause here and try another one. I have one planned for you. Let's move that x to the other side by adding the x. So we get negative 3y equals x plus 9. Divide by negative 3. Divide by negative 3. Divide by negative 3. So y equals 1 over negative 3x. A positive 9 over a negative 3 is negative 3. So our y-intercept is a negative 3. We're going to go down this time. Down 1, down 2, down 3. Put our dot. We're not going to start back at 0, 0. We're going to start from this dot. And our slope is 1 over negative 3, which means I'm going to go up 1, left 3, or if you have negative 1 over positive 3, you're going to go down and to the right. It is the exact same. Let me show you. Up and to the left, it's going to line up with down and to the right. It all lines up. You can do this a couple times if you wish. If you feel like you can make a good line with just a couple of points. That's that. And when you're drawing the lines on MyMathLab, the arrows probably come with, to be fair. All right, is that the end of the lesson? No, I keep going. Look at me. All right, let's do a few more. Pause at any time. I'm going to go a little faster because I just want to make sure you guys have the hang of this. So take the x to the other side. 3y equals negative x plus 15. Divide by 3, divide by 3, divide by 3. I try to create problems where the y-intercept doesn't turn out to be a fraction. It could be, especially in an application problem, but that's not as easy to graph. Gonna go up 5 for my y-intercept, down 1, right 3, down 1, right 3, and draw my line. I tend to make that y-intercept line a little bit, or dot, a little bit bigger than the rest of them, don't I? All right. This one looks a little weird. Remember, if there isn't anything there, go ahead and add in that 0. So all I need to do is get rid of that 4. So divide by 4, divide by 4, and then anything divided by 4, or 0 divided by anything is going to be 0. And so here I'm going to have y equals 3/4 x, and then plus nothing. But of course, if you're looking at this problem on MyMathLab, they're not going to write that down. You have to know that it's plus 0. that y-intercept is going to go through right there. And then from there, go up 3, right 4. And if you want to just do 2 points and connect the dots like that, and just try to really capture where those go through, that's great. All right, one more to try. Let's take that 3x to the other side. 2y equals negative 3x plus 6. Divide by 2, divide by 2, divide by 2. Y equals negative 3/2 x plus 3. So let's go up 1, 2, 3 and put our dot. Our slope is a negative 3 over a positive 2, so I'm going to go down 3 and then right 2, down 3, right 2, down 3, right 2, and draw our line. All right, I hope you find that easier than making the table. If you prefer to do a few of them by making the table, that's fine till you get the hang of this. Both ways work, but this one I think is a time saver. So, yep, that is the end of 3.2. So I will end this one and then I'll start 3.3 on a different video.